Hello, everyone. Today is our last new lesson for Chapter 7. We're going to start by, I want you to try to do this warm-up problem. So please pause, try the problem, and come back. Okay, so in this problem, because B, C, and D, E are not split for the triangle, I cannot use the side splitter theorem. I have to use the fact that I know triangle ABC is similar to triangle ADE based on the fact that BC is parallel to DE. Now, since I have to use the red triangle similar to the blue triangle, I need to use the whole side of AD, which is x plus 1. So my proportion would be the red, the little x, is to the big blue, x plus 1, as the little red is to the big blue, x plus 3. And then to solve that proportion, I cross multiply. So I have x times x plus 3 equals 2 times x plus 1. So that's x squared plus 3x equals 2x plus 2. It's quadratic, so it has to equal 0. So I subtract 2x and 2 from both sides because I never like to have x squared be negative. So that's x squared plus x minus 2 equals 0. And now I need to factor that. So I want numbers that multiply to be negative 2, that add to be 1, which would be positive 2 and negative 1. So that factored is x plus 2, x minus 1 equals 0. So then set each factor equal to 0, x plus 2 equals 0, x minus 1 equals 0, which gives me x equals negative 2 and x equals 1. I need to remember that x is the side of my triangle, so I'm going to reject negative 2 due to length. So now what our new day is about is similarity transformations. So remember when we talked about congruence, we said that a reflection, a rotation, and a translation were congruence transformations. So we have a similarity transformation, which is a dilation. It's a transformation that produces an image that is the same shape as the original, but it's a different size. Whenever we're talking about a dilation, we have to have a center of dilation. It's the fixed point that an image is dilated about with respect to. So if we look at our example over here, it's kind of like when you do perspective drawing. Our center of the dilation is O, and then we made the green triangle by enlarging the blue triangle. So the scale factor is the ratio of the image to the corresponding length of the pre-image. So the pre-image is our original. So it's always the new over the old, or the image over the pre-image. So if it's an enlargement, so types of dilations, we say that K is our scale factor. So if it's an enlargement, then K is greater than 1, and it got bigger. It's larger. If it's a reduction, then K is larger than 0, but less than 1. And this is when it gets smaller. So determine whether an enlargement determine the dilation from A to B is an enlargement or a reduction. So A is our blue image and B is our green image. So for number 1, from A to B, it's an enlargement. And then to find our scale factor, I choose corresponding sides. So remember, we always want to do the new over the old. So in this case, we're going to do B over A. So I'm going to count this part of B, which is 1, 2, 3, 4, 5. And the corresponding part of A, which is 1, 2, 3, 4. So the scale factor is 5 over 4. So I want you to pause and try number 2. Okay, so we're starting with A and we're going to B. So hopefully you can tell that's a reduction. And for our scale factor, I'm going to count the bottom. So this is 1. And of A, it's 3. Therefore, the scale factor is 1/3. So now graph the original figure and the dilated image, then verify that the dilation is a similarity transformation. So I want you to pause and I want you to plot both and then come back. So I plotted my 2 triangles. You can see, unfortunately, in this case, none of them are horizontal or vertical lines. So in order to verify that it's a similarity transformation, I need to verify that the lengths are all in proportion. So I need to verify that DE over AB is equal to DF over AC is equal to EF over BC. Unfortunately, the only way to do that is to find the lengths of everything. So I'm going to use the distance formula on all 6 sides. So the distance formula, remember, is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So please pause and do that for all 6 sides and then come back and check your answers. So you can see that I found the distance of every side. DE was 4 radical 2, AB was 2 radical 2, DF is 2 radical 10, AC is radical 10, EF is 2 radical 10, and BC is radical 10. I showed all my work. If you have any questions, let me know. I then did the ratios. So DE over AB equals 2, DF over AC equals 2, EF over BC equals 2. So the triangles are similar because all the ratios are equal. So that's the end of our video for today. If you have any questions, please let me know. I think I answered everything. Then graph the original dilation and then verify the dilation is a similarity. And also, since I did the image over the original for all my ratios, the scale factor is 2. So again, bring any questions to me tomorrow in class and have a great day.